Okay, I'm going to go ahead and get started and see a few of us here, and we'll continue on. Um, I want to just make sure that we're on top of where things are in the course. So I'm going to walk over uh, into Canvas. We're in Module 9. And as I mentioned on Monday when we met, we're going to cover these two cases this week. One of them is the naive Bayes, that mandrel case. This is from the Data Smart text, where we're going to work with some big data and work with some tweets and analyze them and see how we can use some management science techniques to work with big data. And also then we are starting to put our toes in the water dealing with queuing theory, and that's that single arbitrary case. And I went ahead and devoted an entire class session to it, which I posted. So that hour-long screencast is a supplement to this one. And if I feel like in these 50 minutes we don't cover the mandrel case as sufficient as I want to, then I'll go ahead and I'll add another session this evening, so you can have plenty of stuff to chew on and take a look at. And we're going to focus on the naive Bayes. And of course, now before I go any further, the single arbitrary case, we looked at a single channel and arbitrary service time model, and we're there in that chapter dealing with queuing theory. And so in that supplemental video that I did for you, we walked through all the basics there all the basics in terms of queuing theory and all of the components that have to do with that. And that, as we start to look at some other models, and other than just a single channel arbitrary service, we'll start to see again how we're using probability theory to help determine how arrival times will impact waiting time, and then how service times and changes of those impact the entire amount of time that a person spends going through the queue and being serviced. And so I went through great detail there in the text as it explains that to you, and how waiting time and service time kind of mimic the total cost equation, and in the single arbitrary, I had you manipulate some of the variables and use the goal seek to see what the total amount of cost would be based on the time spent servicing that any customer who came through. Well, we're going to go back here again. This is from the Data Smart text, and I'm going to go back over to Vital Source and just very, very quickly bring us up to speed. Now, let me see before we do that. Oh, I don't want to get ahead of myself. Make sure we have these two cases are due at the end of the week. We do Friday. And I do want to make sure that I know that you take a look at all of these different notes and annotations I provided you about the case for the mandrel case. And I've got here a basic outline that explains everything that happens in that case. And this is from the Foreman text, the Data Smart text, the case 3. I've got some notes here about naive Bayes and types of error, and then I have explanations here as he goes tab to tab in terms of the app tokens that are created and the position spaces, and then the app tokens themselves, and then how we apply the probability to them, and we're using naive Bayes. Okay, it's not the same as probability. Hi, glad to see you also join. And then the test tweets and the test predictions. And we're going to try to finish up here in these 50 minutes, but here's the deal. What we're going to do, the first thing we did on Monday is we looked at how we cleaned all of those tweets up. We took 150 tweets that we knew were about mandrel, okay? And then we took 150 tweets that we knew were not about Mandrill. And we're going to do what's called an ex post facto study of sorts. And that is where we say, okay, we compare those tweets that we know are about Mandrill versus those that are not. We're using a technique, it's called a bag of words, where we're going to look at those tweets and the probability of certain words occurring, okay, versus those tweets that are not about the product, and we're going to compare the two of them. We're going to build a predictive model. Okay, so we're using a management science technique in that we're using probability theorem. We're using the bag of words model, which is one of the ways that people do textual analysis. And we're going to walk through and follow all of that, where we've cleaned up all the extraneous data that are there in the tweet. And so I'm going to open Mandrill up and we'll take a look, and then we'll go from there. As I said before, if I have to do a third broadcast, I'll probably do that. It's just going to depend upon how far I feel like we get and how comfortable I feel that we understand. But the whole point of this is this is one of these examples of big data that you hear people talk about. And this company, MailChimp, which is the author of this book, was their CIO. They provide email services for their clients, and they have a product called Mandrill, and they're trying to determine, as they look at tweets about Mandrill, whether that tweet is about the product itself or something else. Okay, so they're scraping those tweets, and then we're going to take the tweets and analyze them. And we're working with the Mandrill file. It's over there in the Foreman files in the files section of Canvas. And you go in there in the files section, and you'll find in chapter 3, you'll find Mandrill. Or I think you may even have Mandrill stuck there just alone by itself. So I've got Mandrill down here on my desktop, and I'm going to open it up. Okay. And again, I'll go as far in these 50 minutes as I think is I'm comfortable going. And if I have to, I'm going to add a third section. And we may end up having to do this as we move into these more complex models, like the queuing theory models, and as we work with some of these cases out of the Foreman text. The great advantage is you can look at these supplemental screencasts on your own time, and you can go into greater depth with them. Now, I would say this: the textbook, and I've got it open right here, from Vital Source. The textbook, he goes into tremendous detail, step by step, even with screenshots that show you the process that he followed. Okay, but the main thing is this: the reason we're working at this, number one, is that we're following the pattern in management science, where we try to solve a problem using some model that already exists. And so we start with the question of, is a tweet, is it about the product or is it not about the product? And so now we're into the realm of probability. Okay. And he says, well, we're going to use a naive Bayes approach. Okay. And we're going to assume that that there's just a 50-50 chance that a tweet is or is not about that product. Now, that's not what follows classic probability theory. And you'll want to go read I think I have some resources there for you to take a look at about naive Bayes and why people like to use it out in the real world, and why it seems to be of use. And he walks you through, and he says a fast review of probability theory, and that's true. And one of the things we're going to come to is a big assumption. This is why we call it a naive Bayes or naive probabilistic theory, and that is we assume, okay, that the words are not dependent but independent. And as you know from your statistics, that's a big assumption, okay? And so you'll see as we walk through this. And he walks you through here in chapter 3 with the screenshots, everything. He explains almost every single detail. And so I think there's enough meat there for you to get it. So I'm not going to I'll probably pop up some of the screenshots as we get through there. And if where we kind of left off on Monday was using Bayes to create an artificial intelligence model, okay? And he talks about that. And artificial intelligence is a very simple concept at its heart. Is I create something that provides me a decision, or it infers an action. If I have something, for example, that's unsupervised, that would be just let's say I have a sensor that just feeds data to a server. If I have something supervised, then I'm active. I've created an algorithm or some conditional format or some conditional statement that this is why they call it artificial, because I've created it, and based on the condition, there's some response, or I categorize it some way, or there's a default. Okay, so he walks you through this process of trying to determine are these words actually the words in a tweet, do they relate to the product or not? And he's using what we call a bag of words model, where we say that words, if they have if they're part of us, if words have a meaning outside of just their own simple connotation and denotation, that they're connected to some other words in some kind of unit, then we call them a token, and we start to count them, or we look at the probability that they would be there versus not. Give you a good example. If I'm talking about an automobile, and then all of a sudden in an article, and then all of a sudden I talk about a dishwasher, the odds that I'd find the words dishwasher in a review of a car are pretty low. So it's the same principle that we're using here. Well, let's go over and take a look at we'll open up Mandrill, and we're over here on this page 83, and we'll go from there. And I'll occasionally jump back in as he walks us through the tabs, okay? So I'm going to open Mandrill up. And again, we have 150 tweets that are about the product. We have 150 tweets that are not about the product. And we're going to see if we can build a predictive model that will indicate whether a tweet is or is not about that product. And we started with the very first tab here, and you'll notice we had the tweet. Okay, and we have this first tweet. I'm just going to go really quickly here. And so we begin to strip out the extraneous data so we can create what we call a token. And here in this first, we use the lower function. That is, we take everything to lowercase. Okay. Then next, we use a substitute. And what we do is that anywhere we find a period or we find a comma, all right, we put in a blank space. And the reason we're doing this is that when we get to the end and we want to divide these tweets, and we're going to stop at 30 words in a tweet, 30 words. Then as we get those blank spaces, it'll be a simple it'll be a simple process for us to use to separate those values, okay, and just use that tool that lets us separate words or numbers or whatever in a spreadsheet, and we'll just simply use that to separate them off into their own entities. So we'll have 30 cells in a record rather than in a tweet, rather than one tweet with all of them. And here's another where we use a substitute. Here we're getting rid of semicolons, colons, question marks. You can see right here we're using exclamation marks, and we've got quote marks. We're getting rid of those, and then we're always we're using the substitute function to put in a blank where we have any one of those specialized characters. And we'd even put them on lowercase so that we take away the connotation with a capital letter, okay? Now, what we're going to end up with here in column I is the tweet itself. And then if we look at this next, if we take a look at this next tab about other, okay, these are the tweets that we know are not about the product, okay? And we go through the same process of stripping those data and cleaning them up. When we work with big data, okay, these are data that don't fit conveniently into a table format, tabular format. To get them to that point, we often have to clean them up, and it's called wrangling the data. People out in the industry, so I'm wrangling the data. So I'm getting some data, a tweet, comments from Yelp or whatever, stuff from sensors, you name it, and I've got to clean that information up. Or let's say maybe I have data from the housing census from 2010, and the data are there, but they're not in tabular form. Well, I'm going to have to use some type of function that allows me to take those data and put them into a tabular form so I can analyze them. And that's why there's so many people out there who, especially in the hard sciences, use what we call R programming. I've had a few courses in it, and as I look at job openings out there, there are more and more people who want you to be able to work with that type of program. And that programming is designed to handle big sets of data that don't necessarily conform to a table, in other words, column and rows kind of format. So that's what we did there, and we've cleaned the tweets up, okay? And then we have the app tokens. And here's where we start to do some analysis. In this app tokens, in the app tokens tab, and I'm going to pop over. We were over there at 87, okay, after we talked about creating our model, okay, and we've removed all the extraneous, all of that, and we've created the spaces, okay. And now we're at the initial app tokens. That's over on page 89, okay? And let's look at this. Here we have the tweet. This is, and I'll scroll up here. And he walks you through the mechanics of cutting and pasting all this over into a new worksheet. And so we've got the tweet, okay? Now remember, we have 150 tweets. We have 30 words. We could choose 40. We could choose 50. It's up to us in terms of, there is some guidance in terms of what number you'd want to use, but 30 is a pretty good number as far as a sample. And so we're gonna have 30 tweets. We're gonna have 150 tweets, and we're gonna look at 30 of those words, which means we're going to end up with, for the app tokens, we're going to end up with 4,500 rows or records, okay? So we start with the first space position, which is 0, okay? And then I see my first token. And here we have this conditional statement. And it says if we don't find something there, we just simply, we're going to go through and we're going to look at we're going to use the mid function, and we're going to start with cell A2, and then we're going to take B2 plus B1, and that's the next, that's this space position. And then we're going to take B152, because remember, we're working with 30 words, okay? And then we'll take that minus B2 minus B1. And then we have a default, which is just simply a blank space. So we've got the token here. Now, let me say this. I'm going through this conditional statement pretty quickly, but if you go back into the, if you go back in the text, or in my notes that I've put over there for you, it will explain in exact excruciating detail the if error, which is if I find an error, here's what I do. Here's a condition, and if I find an error, here's how I respond. And the mid function, as I said before, he uses these functions in a pretty clever way. So the first token there is the word blog, and we look at its length, okay? And we're going to assume that the letters used in a tweet have the probability that a certain word with a certain amount of letters would show up. We're going to compute that probability. Now we already know that these tweets are about the product, but we're going to take each word because we know the sum of the probabilities equals 1. So we're going to take each word and we're going to get the length of it. And then we're going to do a little bit of work. We'll standardize these data, and then we're going to convert them to log numbers. We're going to use it into log natural numbers, and then we'll do our computations to see about their probability. Here we've got this word token, okay, and its length is 6. And over here in column D, I use the length function in Excel, and we start at 6. We come to the next space position. Now we're still working at position 0, okay? And we have the word blog, and it's 6 spaces. It's a length of 6, and that's blog within brackets. Now we come to the next. This is record. This is the 4th record, and here we have at Albertson. And so we start at 0.0, and then we come to the Albertson token, and it's 11. And you'll notice we start at space position 0. I'm going to scroll down here. You just kind of have to walk through it to see this, because coming into it cold, it's not very intuitive. But you see all these 150 words at 0.0, space 0, and then you'll notice at the 150th record, the space position is 7. So how did you get that? Look at the record there, 152, and you're going to see we started at space 0, and blog is 6 spaces. Okay. Then we're going to look at the next token that we find. These words we've converted into what we call tokens, something I count, okay? And we see that space position, the word using, starts at the 7th position, okay? And we see that the word using has a length of 5. And this process will be repeated 30 times as we choose the 30 words. And you'll notice we started at 7, and then when I go down to row 302, it's going to start at null mailer, whatever how many ever spaces that is. You can see, let's go down there. We'll look at 302. So that'll help you understand how we're getting the token value. Remember, we have 30 words and we have 150 tweets, so we have 4,500 records about that are app tokens, 4,500 records that are about other tokens. Now, notice that we came up and we're down to 300. And here at record 302, okay, we're at space position 13. Okay. Now we've found some found some words at some other space positions, but we're here at 13. And we count the number we get the length of it using the length function. And we just go through that iteration 150 times, 30 times for the 150 records. If you scroll all the way to the bottom, you're going to see that we work with the 4,500 records. And we get the space position and we get the token. And you'll notice as we come down here to the end, we have the default, which is a period, and that token, and that's a length of 1. Now, we had cleaned these out. So you say, well, how did the period end up back in there? We put it back in our conditional statement. I'm going to put my cursor right there in cell 4501, C4501, and notice what's going on. I've got if error, if I find an error, and then I have the mid function involved there, so I'm looking for the middle point, and I go through that 4501, A4501, and then B4501 plus 1. We're adding 1 to these numbers to get them to a length, and then minus, to take care of that length as we do the count. And then we've got the count of B4651 minus B4501. And if I find an error there, then I get the default, which is the period. And we simply do that in the other tokens. Okay? It takes you a little bit of while. You could notice I even have to stop myself and think clearly. But what we're doing is we're counting these words and we're using the function to do that. And we repeat the same process with the tweets that we know have nothing to do with the product. Okay? Then we're going to compute the app tokens probability. Now, after he walks you through getting all of that business done in terms of counting the space and their spaces, their respective lengths, over on page 92 in the text, and I'll pop it up here if you don't have your text, I'll go to Vital Source. Because you almost have to follow along with this. He creates a pivot table, okay, and then he uses we do some filtering to come up with items in terms of multiple items in terms of their lengths. So we have them organized, and we have over here. We have the multiple items, and that's set up as a filter, the length, okay, for this pivot table. And then we have the row labels, and we have them set up for totals. The count of those tokens, the count of the row label, of the rows. Now, over on page, I'll find this here real quickly. He talks about some issues with undertow, and that is how accurately, when we take a probability or any number out past a certain point of zeros, how accurate it is. And he walks through, I want to find this for you here because yeah, here it is. It's over page 86. He talks about floating point underflow and the fact that as we get out there further and further and further to the right of zero, we're going to lose some accuracy, or we're going to get some numbers that are so infinitesimally small that may not be worthwhile to even try to work with. So we're going to standardize them by adding 1. Okay, so we add 1 to every one of those, and then we compute the probability. Okay, and that's what we've got going on here in the app tokens probability. Notice we have Friday, and it showed up 1 time. out of those 150 tweets, the word Friday has only shown up once in the tweets that are about the product. Now, that makes sense, okay? And then we add one to that. So we're adding one to every single one of these. And then we get the app token probability, which is C5. That's the row we're on, divided by C828, which is the total number of words pulled out of here. And there are 2,410 pulled out. Okay? So you see this first, and I'm looking at the word Friday, and the probability that it's a token, say, versus an app. And I want you to notice the notation here. Okay. We've got the word token, then a bar, and then app. What we're assuming is that this token is used because it's an app. Now, because we're using Bayes, we can flip this and say, well, it's in the app because it's a token that relates to apps. And again, we've got some resources there for you to go back and look at all that. Bayes is a fairly controversial approach, a quick and dirty approach, but that's what they're telling you here when you see that notation. Then we use the logarithm. And anytime you want to, you could just click on the insert function. It'll tell you, okay, what you're looking at. And I'm gonna put equal len as if I'm going to use it. And this is one of the great advantages. This returns the number of characters in a text string. Okay. So we've got that text string there, and away we go. And notice we've got the len with the probability. And we've just got that carried all the way on down. And you'll see, as you scroll through, you're going to see some words that have a lot of occurrences. You go, okay, well, that makes sense. And some words that you go, well, I don't know. We're going to go through the same process in the tab when we deal with the other tokens probability. Remember, these are tokens that we've created from 150 tweets that we know are not about the product. Okay? So we're going to build a predictive model here to see how accurately we can use this model in terms of the words that we know that are tweets. We're going to use the sum of their conditional probabilities, and we're going to look at word by word by word by word, tweet by tweet, to see if we have a model that works. So we've got the other tokens probabilities, and again, you're going to want to take a look at the text. I have a lot of extensive notes for you there, okay? And the truth is, this one textbook alone, we could spend the whole semester. It's so full of all kinds of things, especially about the use of Excel, some very, very clever ways that we can do some data analysis. We've done cluster analysis in our first case, and now we're doing this. And so that's why I use this textbook, so that you can see how we take management science concepts, and that is we find a model, okay, that works or seems to be descriptive of the world, and we apply it in a given situation. And we're working with probability here, and we're saying, okay, if a tweet is about a certain thing, then there's a high probability it's going to have certain words. And that just makes sense, okay? And this bag of words technique, which is a technique that folks do use in what they call textual analysis. Well, we've got the other tokens. We walk through the same thing, that same process. We get the total and we add 1 to everything. And notice here, this time we're looking at the probability of the token being the other. In other words, it's not about the product. And we have the ln. And that returns a logarithm. Remember, we added 1 to everything, okay? And now, you say, well, why did we go to the logarithm? Simple. We purify those numbers as much as we can. And when we return the natural logarithm of a number, we have as close to a real number as we can possibly get, and one that's manageable and workable. This is no different than if we do ratios, which clean up data, okay? They can take out distortions. And you know this from just having worked with accounting ratios, okay? That we use ratios that because of the size of 2 different companies, maybe in the same industry, we can use the ratio, the division process, to clean the data up a little bit. So we've got the natural logarithm here, the probability. And so we've taken these tweets, we've cleaned them up, okay, and we've created, we've calculated the probability of each of these words occurring, and we have the number of times it occurred and the number of total words that occurred, okay? Now, let's click on this test tweets. And you're going to see that as we come through here, we've got the tweet. And we go ahead and do some more cleaning with them. The substitute in the lowercase. And then we have 10 we choose 10 tweets that are about the app. We choose 10 that are not about the app. Okay? And then we do some test tweet predictions. Now, I don't want you to miss this. On page 94 and page 95, okay, he talks about using text to columns and that wizard. And you'll want to take a look at that. And is often the case, what you're going to find is there will be many times where you're going to want to use delimiters, okay? So that I can take let's say maybe I'm given a spreadsheet with the address and first, last name, the street address, the city, the state, the zip. And the street address is in one cell. The city's in another cell. The state's in another cell. The zip's in another cell. And then the first and last name. They're in one cell. A nightmare until I use the delimiter, and I come in and I choose a delimiter between the two, between the first name and the last name, and boom. Then I have a column of first name, last name. All right. And this is a pretty simple cleanup, and you're going to run into this a lot when you're out at work with people who create spreadsheets, or they may even create records in a database, and they don't understand about the idea of every single unit needs to be a separate unit, okay? When you have somebody when you see a database that has first and last name in one field, run for the hills. Because if you have people who have multiple last names of the same last name, running the query will be a nightmare. So they walk you through the converting these text to columns. Okay, so don't forget to take a look at that, and he shows you how to use the wizard. Some of you probably have used it before, but so that you've got everything all chunked up. All right, now let's look at our test, and we've got our test tweets. Okay, we've got 10 of them that are about the app, and we've got 10 that are not about the app. And we're going to do some predictions. Okay, I'm going to start over here, and I'm in this tab, the tweet predictions tab, and I'm at cell A2. Okay, and this is the first tweet, and we know it's classified as an app, and we're going to predict that it's an app, and we're going to use a conditional statement. Okay, and what it's going to say, if C25 is greater than C48, then we're going to call it an app. If not, the default is, of course, other. Now let's look at this. C25, and we'll go down here to C25. And C25 is the sum of the conditional probabilities for that word. Okay? And then we're going to compare it versus C48, which is the sum of the conditional probabilities for the words that are not about the product. Okay? That's why I've said to you over and over throughout the course, management science, this is probably one of the most important courses that you'll take, because it's as upfront with this as possible to say, when you want to solve a problem, okay, here's a process. First of all, understand that solving a problem is not the same as making a decision, okay? It's not the same. And so we use the optimizer. We choose an objective function, something I want to accomplish. We're building a model, and if we can build a mathematical model, all the better. That's going to be the one that we can manipulate the most. We can put it through all kinds of random trials to see if it works, etc. This is why simulation is going to become such the kinds of things that we see today, the very exotic things that big companies do with simulations, those will all be on your desktop in 25 years. Okay? But I digress. So I've got the sum of the conditional probabilities if it's not a tweet versus those if it is. Okay? And I get a prediction that it's an app. Why? Because C25 is larger than C48. And then I'm here on, I'll go back here to number 2. This is up here, and this is classified as an app, and the word just, okay? And this, well, the whole tweet, I apologize, we worked with the whole tweet. We got just, love, mandrel, and we just walked down through here, so I apologize. So here in row, in number 3, okay, I've got C26. If it's C26 is greater than C49, it's an app. If not, the default is other. And as we roll along here, we're looking pretty good, okay? And we come down here, and so far so good. All 10 of the apps, the test tweets, excuse me, are about the app, and we predicted them that they would be. Again, using the sum of the probabilities, and that sum is the probabilities of those words all summed together. Okay? So we're using probability theorem, roughly. Okay, not as exact. I'm sure if somebody in the math department heard me, they'd be beating me over the head because I'm not doing it as purely as we want. But in the real world and out in the world, like a business where you got people and you've got roughshod kinds of things, it's not possible for us to get a pure signal. We always have a lot of noise, lots of noise. And so we try to work and live with that. As I've told you before, the decision-making process is not binary, it's continuous. When we make a decision, okay, the outcomes, are not binary. The outcomes, it's not right or wrong. It's degrees of how right or wrong or accurate or inaccurate we are. We just hope and pray that we're within a zone we can live with, because if not, it's going to be a bad day. It might be a really good day. So we'll work down through here, and we're looking at the app, and all 10 of these so far, our predictive model has worked. So far, so good. We're going to go down here and start to look at the tweets that are classified as being other. And we know they are because we know they have nothing to do with this. Again, we're using this ex post facto model where I'm taking something after the fact and looking at it. And I start here, and I've got this tweet number 11. But notice something as we come down here at tweet number 19. It was classified, and we know it is not about the application. But if I come here to column C, I'm in cell C20. I do this conditional statement. And if C43, the sum of the probabilities for this tweet is greater than C66, then it's an app. Otherwise, it's other. And what we find is, if we look down at C43, and to just help you through the maze of all of this, just click on the formula bar so the numbers and so the cell references go hot and you can see them. And there's the blue, and this is over here, and it's minus 61% probability. And then we come to the sum of the conditional probabilities for 19, and C66 is greater than C43. So we classify it as an app. But it's not. This tweet is from one of the tweets we know. These are the words broken out. These are the tokens, the part of the bag of words just for this one tweet. And what we find is that it's using our model, it's classified as an app when it's really not. It's not about Mandrill. Okay? So, again, I would leave it to your devices to if you really want to comb into the great details in this chapter. But I think I've provided you enough aids, and I think he gives you enough detail in the textbook to help you explain to you the process that he's used here to determine whether or not a tweet is about the app, about an app, or a tweet is about something else. Now, so that you understood and to reinforce to you that this is just not some esoteric exercise I put you through, okay? I wanted to make sure that you go down and look at the resources I provide you over here. I have a link here that talks about the impact of spam. And when we started on Monday, you'll recall that we talked about the fact that MailChimp, they provide services to companies in managing their email. And let's just do some real simplistic thinking for a moment. Let's say that you employ 500 people, okay? And their average salary is $20 an hour, okay? And throughout the course of throughout the course of the year, let's say, I don't know, you're talking about everybody, an average salary is 40 grand, something like that. I think you know where I'm headed to. Every minute these people spend looking at an email that is this is not related at all or not necessary, or the minute one of them hits one that's not about anything of importance except it's a phishing email, then all trouble breaks loose. The amount of time that people spend going through their email, getting rid of the junk that's in there that they don't need or don't want, the time they spend putting stuff into folders can become a significant productivity issue. And I can tell you, I try to keep up with my email at work. It drives me nuts. And personal email, the same story. So MailChimp provides a service that helps filter stuff for everybody. And that's why sometimes you'll get, let's say you buy something or maybe you register somewhere and they'll tell you, make sure if you don't see our confirmation email, go look in your spam folder and you'll find them. And so they put into great practical terms why folks like MailChimp, why this company exists and why these are such valuable tools. Now, just so to bring it back home, if you're using your OB email, which you should be, you'll notice in Outlook has a thing called clutter. And I'll get an email every now and then that says, we think this is just junk. It's clutter. You want to keep it? You want to get rid of it? It'll tell you what the topic is and how many emails you have, which will tell you that we're working on a case that is based in the real world. This is just not some stupid business theory or some reason to put you through a grinder. This deals with a real problem, and that is emails and how they can overwhelm the amount of time. Well, if you have 10,000 employees and they spend even 20 minutes a year on fiddling with their email, getting the folders and things organized and trying to swim through all the extraneous junk that they get, you're talking about 200,000 minutes of their time. You can divide that by 60 and come up with the number of hours, and you can take that times the average hourly salary and fringe, and you can put a price tag on it. It's expensive, and it lowers a tool that's meant to make us more productive. As we've found a way to use it to make us less productive. Well, I think that gives you a good run through on this chapter. And again, you can always come back and take a look. And if you have questions, let me. If you really want to really put your teeth into this, let me recommend that you do this. Open up the Mandrill file, have the book, follow along. Or have it open and take a look and have the book and then take a look at my notes that I have there for you as I guide you through the process. Then you can always come back and listen to this screencast. But you can see how we've used management science techniques, management science principles to deal with a very common problem, and that is email clutter that comes in. So, and I've got some references there that deal with naive Bayes and how to understand it, how we use it with data mining and informal inference that we do with it. And then, as I mentioned here, the real impact of spam, another resource. Here is the book I talked about the other day. I mentioned this. This is a tremendous book that talks about Bayes' rule and how it's been used and how controversial it is. And then over here, you remember Monday I talked about this. I have a link here about the case for the resurrection of Jesus, and it talks about the probabilities when Paul talks through 2 people saw him, 12 people saw him, several hundred people saw him, and we had the accounts that he was here 40 days. And so, let's just take for a moment, okay, the 2, the 12, as Paul walks through this ever-growing number of 2. One person saw him, then 2 people saw him, then the disciples saw him, and then as many as 500 saw him. All right. And Paul even says, many of whom are departed. But he was also saying, flip the thought to say, a lot of people who were around, so any of you who were around at that time, let me know if you didn't see him. And he really never, he never got a telegram that said, hey, that didn't happen. And the fact that we see that the Lord was there for 40 days, he ate with them. They touched him. The resurrection, on which all of our faith is based, is a reality. And I can tell you this, if you go through those numbers of 1 person saw him, 2 people saw him, 12 people saw him, 500 people saw him, I don't care whether you choose that they're dependent events or independent events. Either way, the probability that all of those people were lying is so infinitesimally low, it just defies the imagination. And so for me, I think this is a great article, and I'll link it over there and let you see it, the permalink for it. And this is, indeed, it is an entire book. And he walks through the case for the resurrection. He goes through all the evidentiary kinds of things, and he also talks about the probabilities, the probabilistic argument in favor. Well, I'm not going to take up an offering, and I've done all the preaching I'm going to do today. And I think we've covered this fairly well. So if you have any questions, I'm going to stop now. And anybody have any questions, let me see if you've got any. Anybody have a question I could help you with? Okay, folks, thank you very much. And don't forget, I sent you an email about my virtual office hours today. And I don't have any today, but this evening I may, and if I do hold some office hours, I'll post something and send it to you in the event you need to reach me. Otherwise, you've got email. Okay? Thank you very much. We'll call this a day. I appreciate all of you who are here, and we'll be moving on to the next module. Let me take us over there. Moving into some fairly complex stuff. And we'll be moving next week into Module 10. And we're going to do another work with the Foreman text where we're going to look at outliers. Another one of those situations where we can use some management science techniques to deal with a simple problem. And we're going to continue on with looking at queuing theory, where we will look at the single the Burger Dome problem, and that again is over there in the Chapter 11 files, and understanding that particular type of queuing problem. Thanks, folks, and I will see all of you on Monday.